All right, here is section 8.2, integration by parts. And the way they ask it is kind of a little different. They'll do it more in symbols, but if you don't understand integration by parts at all, then it's impossible to do, so we need to kind of go over that. Integration by parts is when you got a product like x cosine x sine x. You got a product and there you can't do substitution. U du does not work. Like I go, let's set, no, none of that works. So that's when integration of parts is when you have a product of two things that don't go together. If you remember, we refer to this as of-dov, a little shortcut that we can do. So this is one of them has to be u, the other one has to be dv, because they have nothing to do with each other, but we can do integration of parts if we treat one of them as a u and one of them as a derivative of dv. So we pick u to be our x, or x to be our u, because you want to pick something whose derivative goes away when you do integration of parts. So like x's derivative becomes 1 and then becomes 0. It'll disappear. This guy's derivative goes forever. We can keep taking derivative for the rest of our lives, so that we don't want that to be u. So the derivative of u is 1 dx. And the integral, don't forget, we're taking integral because we have dv, we're looking for v. Integral of cosine is sine. All right, so the integration by parts, if you remember, was uv the integral of u dv, if you can't see, it's in your notes, is uv minus integral of v du. So uv, which is x sine x, minus the integral of v du, which is this one. So where we got of-dov, if you pronounce it this way, of-dov, you can kind of see of-dov. That's where some came up with. So it's this minus integral of this. So when you do the first step, you're not done, but your integral is no longer a product that we can't do. It's just a single sign, which I can finish. And that's it. So this is integration of parts. But remember, we have a method called tabular. I would choose tabular in most cases. Now, since x is to the first power, tabular is not going to be much faster. It'll be about the same. But when this starts to go up in power, we'll talk about that next. So, same question. If I'm going to do tabular, let me just erase that there. We make two columns. We're going to take a derivative of this column, integral of that column. So the one again who goes away, we take every derivative till it gets to 0. Derivative of x is 1 and then 0. The other guy, we take his integrals, and we want the charts to be the same length. All right? So remember, all we're going to do is multiply these together, going diagonally, and then there's a multiplier of plus and minus as you go, to keep alternating. So this is, final answer is going to be x sine x. Now the minus and a minus, so that's plus cosine x plus c. So you see I get the same answer, it's just a different method. But tabular starts to earn its money when this becomes x squared. If this is x squared, I would have to do integration by parts twice, because after I did it once, I would still have a product and I just have to do it a second time. But tabular would be much faster. So let me show that real quick. Tabular. All right, so let's say this was x cubed cosine x. I do not, well here, I'll even change this to ex. I do not want to do 3 integration by parts. That's how many it would take to get rid of x cubed. So I do tabular. All right, take the derivative of x cubed, derivative of 3x squared, 6x, and 6 and 0, right? So then I take the integrals of e dx. Well, integral of e dx is itself over and over. That is, make sure those columns are the same. So my solution and remember you alternate signs again. So your solution is x cubed e dx minus 3x squared e dx plus 6x e dx minus 6 e dx plus c. Okay? So that's tabular method. So those are the main things you have to know. The special cases that they started teaching us, what if you have ln x or arctangent or arcsine involved? Then you have to integration of parts. Tabular is no longer a choice, all right? So let's do one of those. Now, remember that x cubed from the e to x, I'll have to do it 3 times, but the special case is when you have these ln or arc, they have to be your u. So for the second one, you would have to let u equal arctangent and so forth. And whatever's left of dv, so derivative of ln x, and take the integral of this. The issue that people have is they don't realize that when you multiply these two together, when we do the dov part, the x's are going to cancel, and it makes it simple. But if you don't cancel x's, you're torturing yourself. So the of and when I do the dov, some people will multiply it over and go, man, I don't know what to do. Well, cancel that x. That x cancels the fourth and makes a third, and now it's a simple integral. So people think it's hard, and it turns out it's never hard. And that's it. And so that's how you do the integration by parts. So I did this one in your notes and previously and stuff, but those are the special cases. The second special case is when neither one goes away. That one you have to do twice and send it over. It's never been asked on an AP test. You know, I can show it. So let's do like e to 2x sine x. Neither's derivative goes away. Derivative e is forever, derivative sine is forever. So this is special case 2, where you have to do it twice and add it over if you forgot. So you pick one of them to be u and the other one to be dv. It doesn't matter what you start with. So I'm going to pick, like it's written, the derivative of e to 2x. The 2 pops out. Integral sine is negative cosine. All right, I do my first of dov. The formula is of minus, and then when I do dov, I get a minus. I like to bring out all the constants, if you guys remember. So I bring out the negative 2 up front. All right. If I bring everything in front, then I only have to do integration of parts on this part. So now this is the important part, is since I picked e first time, I have to pick e the second time. I have to pick the same equation. I can't switch it up or else I'll get back to where I started from. I'm taking this derivative, this integral. All right, this part's already out. And there's a 2 multiplying whatever of dov I get. So of dov is e to 2x sine x minus, again I have a 2, so I'm going to bring that 2 in front, and e to 2x sine x. Cleanup step. Bring that straight down, this 2. And I get a 4. All right, so this 2 times that 2 makes a 4. All right, so we've done it twice, and remember, it's still just as ugly as when it started, but you have in your answer the original question. So erase this part. I can add these 4 over here and give me 5 of these. Because remember, this equals this still. Then, to solve for this, because that was the original question, we can divide by 5. So I can divide. And then I now know that this, and then I'll put my little plus C. And that's integration by parts. So you just got to do it twice, add it over, all right? And that's our last location. I've not seen that on a test yet, okay?